David Burr is a distinguished professor at Indiana University. Dr. Burr's research activities include the study of the response of bone to mechanical stimuli at the cell and tissue levels, pharmaceutical treatments for osteoporosis, cartilage repair, and the biomechanics of stress fractures. He is the author of more than 250 research articles in the peer-reviewed literature and 5 books on the structure, mechanics, and fracture of bone. Professor Burr, thank you very much for taking the time to join us this afternoon on Modern Healthspan.
Yeah. Happy to be with you. Thank you.
Okay, thank you. So Professor Burr, you have been studying bone for a very long time, and I think you're one of the foremost experts on it. So could you introduce some of the function and the structure of bone?
Sure. Yeah, I mean, many people think of bone as just being a hard, inert substance that's not really living, but in fact, it is living. It has living cells in it, and it performs a number of different functions. One is certainly structural. I mean, something to attach our muscles to and helps us move around and so forth. But it's also a source of minerals, of calcium and phosphorus that we need, and particularly calcium, is important for the neural system, for the brain functioning. And if we get low on calcium, this creates all kinds of problems for muscles and for cognitive issues. And so bone is a place where we can store that mineral. So that's one of the things it does. What people also may not realize is that portions of the bone actually are blood forming organs. So the bones also in the marrow have certain parts of the marrow have blood, and they form blood cells. And so that's another function. And then, of course, that they serve a function of protection as well. So the bone, encases our brain. We have ribs that protect our vital organs, and it serves that function as well. If you'd like me to talk about the structure of bone, I can say a little bit about that.
That would be good. Yes, please.
Yeah. So bone is composed of several different kinds of substances, and as you mentioned, that most people realize that there's mineral in it, which makes it hard. That mineral is something called hydroxyapatite, which is kind of a long formula, but it's kind of a calcium phosphate with some other things in it, and various things can be substituted into it as we age, which may make the mineral a little more brittle in some cases. So there is a mineral that forms that constitutes about 66% of the weight of the bone. In addition to that, there is collagen. So collagen is an organic material. And it is, which means that it's not inert. And these two things together, collagen comprises about 20% of the volume of the weight of the bone. And these two things make bone what we call a composite material. So the mineral gives it a lot of strength, but the collagen actually gives it what we call ductility. It allows it to bend a little bit, so that if all we had was mineral in the bone would be very brittle, because minerals are very brittle, and it would break very easily. But putting collagen together with the mineral makes it actually a material that can withstand a lot of weight and can survive for a lifetime. In addition, there are two other things that are very important in smaller amounts in bone. One is a group of things called non-collagenous proteins. So collagen is a protein, but there are also proteins that are not collagen. And these proteins actually have many functions. There are a number of them in bone. Some of them will control the organization of the collagen, the size of the collagen fibril diameters, the arrangement of the collagen. And others control the way that cells respond in some cases. In addition to the non-collagenous proteins, there is water, which is often ignored in bone, and some people may not realize bone even has water in it, but about 10% of the bone is actually water. of the bone tissue itself, exclusive of the marrow. And there are several different compartments of water in bone. Some of the water resides in pore spaces because there are holes in the bone. But there's also something called bound water, and this is water that is actually attached to collagen, or in some cases it's attached to mineral. And it turns out that this bound water is really, really important in fracture resistance. And that if you change the amount of bound water you have, you can either increase the risk of fracture or decrease the risk of fracture. So that's, we're just learning about this, that water is really a very important component of bone. It hasn't been tremendously well studied.
Interesting. Yeah. So when you're thinking about health of bone, right, how do you say, so what determines whether bone is healthy or unhealthy? And how do you measure that? But let's say, what determines whether it's healthy or unhealthy?
So there are several things. Really, it's a combination of the amount of bone you have. That's something we can measure by looking at bone density. We can talk a little bit about that. The health of bone is also determined by the way that the amount of bone by that bone that you have, how it's distributed in the bone. So if it's distributed in different ways, the bone can be stronger or it can be weaker, even if you have the same amount of bone. And the third thing that contributes to the health of bone is the quality of the material. And there are several things that determine the quality of the material. The quality of bone is everything else besides how much bone you have, basically. And so that includes architecture. As I said, it's important where bone is and how it's arranged. It includes things such as the rate at which bone turns over, bone remodels. Cells remove bone and then new cells put down new bone. So that's an aspect of quality, how that system works. And accumulation of microdamage is also an important aspect of bone quality. So and also the quality of collagen and mineral. If the mineral is not composed the way it should be, sometimes you can have substitutions in the chemical structure of hydroxyapatite, like substitution of carbonate or substitution of strontium, that will change the properties of mineral. Or collagen, which is cross-linked in various ways. So all of these things are actually aspects of bone quality, which are very important, independent of bone density, independent of the amount of bone that you have in bone's health and its resistance to fracture.
Thank you all for watching. I hope that you found the video informative. Please do hit the thumbs up button, subscribe to our channel, and hit the bell button for new video release notifications. It encourages us to continue to create more videos about anti-aging and extending healthy lifespan. Thank you so much for your kind support. I wish you all well and will speak to you again soon.